Okay, what I want you to do, let's take a look at the lab. Because I honestly kind of want to do the lab before I do the work, or at least I want to go through a little bit of it. What I would like you to do is I would like you to predict whether or not these solutions are acidic, basic, or what? Neutral. That's what I want us to do right now. Now, are you going to be okay with just the names, or do you need the formulas as well? You need the formulas? Well, it's a good thing we trained for like a week at the beginning of the semester to go from names to formulas.
But if it says acid in the name,
are you pretty sure it's an acid?
Yeah.
Yeah, I would be pretty sure it's an acid. Okay, do we want to, I'm asking you, do we want to go really quickly and see and go through all the formulas for these things?
Yeah.
Okay, acetic acid, CH3COOH. And my smart board's going to really mess things up because I'm drawing in a table, so it's going to be weird. Okay, ammonia is NH3. Calcium hydroxide is Ca bracket OH2. Calcium oxide is CaO. And solid or aqueous, depending on, right? Hydrochloric acid, you need me to tell you what that is? ACL. Sodium carbonate, Na2CO3. Okay, big difference, huge difference, a world of difference between sodium carbonate and sodium hydrogen carbonate. Sodium is 1 plus, hydrogen carbonate is 1 minus, so NaHCO3. Sodium hydrogen sulfate, NaHSO4. Sodium nitrate, NaNO3. And then the very last one, sodium hydroxide. What I want you to do is I want you to go kind of as fast as you possibly can and go through and try and label these as acids or bases. Or neutral, sorry. If they're not acids or not bases, then you can assume they're neutral.
I'll do it in the price of this company. Ammonium is a base, so I'm guessing ammonium.
I just feel like it's a trick question and I don't know. Yeah, but it doesn't have OH and H is kind of
We're going to definitely talk about it.
I think it's
Are you it? Okay. Regardless of what you thought it was, okay, regardless of what you think these are, I just want you to think about, okay, are these things acids or bases? Are they neutral? Because we should know what bases are by now, right? What are all bases? They're all ionic hydroxides, right? So there's a couple things in here that we can immediately label as bases. What's the first base you run into? Calcium hydroxide. What's the next base you run into? Sodium hydroxide. Ah. So, again, whatever. I don't like Microsoft Word. It's all good. So let's think about this. The acids, we can safely assume are acids. The ionic hydroxides, we can safely assume those are bases. And for the most part, we're thinking, everything else is going to be neutral or something like that. I mean, maybe you have a differing opinion, but then that's totally fine. What I'm going to do is I'm going to take a chemical. I didn't realize this. It was labeled as calcium oxide, but it's really, the bottle is magnesium oxide, okay? Now, it doesn't really change anything. All it changes is instead of CaO, it's going to be MgO. It's magnesium oxide. It's relatively the same thing. Roy, can I bug you? Sure. What did you say magnesium oxide was? Acid, base, or neutral? You said it was neutral. Let's try this out. I'm going to put some magnesium oxide in here. And if it's neutral, how am I going to be able to tell? Yeah, the red will stay red and the blue will stay blue, right? Okay, no problem. So let's try this out. I got my magnesium oxide in here. There's a tiny little bit. I should have used a spot plate, but I had a beaker ready to go. What should I do with my litmus paper? Rip it in half. I should at least rip it in half. Trying to get the maximum bang for our buck here at the school. No, it's a little bit more than that. Okay, let's try this. I'm going to put the blue in the magnesium oxide, and unsurprisingly, it looks like, I don't know, you see any change in color? No, okay, blue stays blue, perfect, no problem. I'm going to put the red in the magnesium oxide. And let's try this. Are you seeing any change in color?
No. Kind of.
It's kind of changing color. Would you agree with that? It does not look like the red we started with. So what do you think? It's this solution at the very least is mildly basic. Okay? So this solution is basic, and today we want to try and identify why. Why is it, or how can we talk about it being basic? Yeah. So if the oxygen steals a hydrogen, it will become hydroxide, right? And remember, those protons, those hydrogen ions, they're pretty easily stolen, right? They're pretty loosely held. So what we want to do is, we want to go into the lab, but we got to learn about something just first. Is that okay? We got to learn about some stuff first, and then I'm going to stick you out into the lab. So let's put that to the side and take out your notes. If we need to take some time, and if we need to continue on this stuff tomorrow, that's totally fine. Okay, so remember, there's this idea of Svante Arrhenius proposed the idea that acids, they have hydrogens and they donate hydrogen ions. So they give off hydrogen ions. Is that accurate? Do you remember, can hydrogen ions exist by themselves in a water-based medium? No, they can't. The moment you get a hydrogen ion or a proton in water, it immediately attaches itself to a water, right? And then it can hop from one water to another based on what collides with that first water. Bases are ionic compounds that dissociate into a cation and a hydroxide. So right, lithium hydroxide will turn into lithium and hydroxide. That's pretty easy to explain why that's a base. Would you agree? It's a base because it contains hydroxide. They separate, they turn into hydroxide, okay? But we know that this isn't true. Problem number one is sodium acetate, acidic, basic, or neutral. I'm wondering, when you look at this thing, what do acids always start with? Either H's or they end with COOH. Does this start with an H?
No.
Does it end with a COOH? No. Okay, so it's not acidic, we're assuming. Is it basic? Does it have an ionic hydroxide in it?
Yeah.
It's ionic, but is it OH? No, it's not, right? This is 100% a basic solution. I agree, Akul. What we have to do is we have to reframe our perspective. We have to take into account new information. This is basic. Is that confusing to you? For a lot of people, that will be confusing. Sodium hydrogen phosphate, is it acidic, basic, or neutral? Does it begin with an H? Does it end with a COOH? It could be basic.
It started with the group 1.
Yeah, it's a group 1, but is it a hydroxide?
No.
No. Well, it turns out this is acidic. Okay? Just calm down. We're going to learn why this is in a second. So we have to kind of reframe what we know. As you can see, there's something that's clearly wrong with our definition of acids and bases, right?
Yes.
There's something very wrong. So let's kind of learn about it. Now, this is a wall of information, a wall of text, as I would say. What I want us to do is I want us to slowly think about this. And I want us to try and really pay attention and see what is the steps of trying to figure out these Arrhenius equations. Okay, the modified method, this is nothing new, tells us that acids react with water to produce hydronium, right? Bases react with water to produce hydroxide. So all we have to do is we have to ask ourselves, okay, is the solution actually acidic or basic? Again, when I look at my solution that I had earlier, this is the red litmus that I dipped into that solution. Has it started very clearly turning blue? Yes, so that is obviously a basic solution, that calcium oxide or the magnesium oxide. So we're going to follow a list of steps, and these list of steps will help us explain what we're actually seeing with the pH paper. Now what you need first is you need an observation. You need to actually know if it's acidic or basic in order to do this stuff. So, rules for writing modified Arrhenius equations. Step number 1 should say, do you know if it turned red litmus blue or blue litmus red? Like, step number 1 should say, do you know if it's actually acidic or basic? Because you need to have that information. Write the chemical formulas for the reactants, or the molecule, or the polyatomic ion plus water. So what we want you to do is we want you to ignore any group 1 or 2 ions, and we also want you to ignore any group 17 anions. Evidence from a lot of compounds shows that these ions do not produce acidic or basic solutions, so we ignore them. What that means is that group 1, 2, and 17 ions are often spectators. Have you ever heard that term before? Yes. What is a spectator? Somebody sitting back and watching other people do all the work, right? So a spectator at a sporting event, you're watching other people do hard, laborious things, but you're not actually involved in the process, right? You could be there, but you're not doing anything. That's what a spectator is. Okay, if the substance is a non-metal oxide, we'll talk about that a little bit later. So a non-metal oxide is like anything oxide that doesn't include a metal. So carbon something oxide, carbon dioxide, carbon monoxide, sulfur dioxide, maybe even nitrogen dioxide, that kind of thing. Okay, so we'll talk about it later, but we'll include that. If you have something like that, you got to use 2 moles of water for every mole of the substance that reacts. Note the evidence provided, right? Remember, is it acidic or basic? And write what it turns into. If the final solution is basic, then hydroxide is produced. Complete the other product by determining the combination of atoms and charge required to balance the chemical equation. The other product should be recognizable chemical or formula, usually a polyatomic ion. Okay, I know that that's a wall of stuff. The best way to learn is just do it. So let's do one together. Sodium cyanide. Let's write out the equation for sodium cyanide. What's sodium cyanide? First of all, is sodium cyanide ionic, molecular? What is it? It's ionic, right? Metal, non-metal, or metal polyatomic ion. So sodium is 1 plus, cyanide is 1 minus. So sodium cyanide. What I want you to do is I want you to go back and read, or like look at the top of your page and read step 1. So write the formula, but what do we have to ignore? 1, 2, and 17. Is sodium group 1, 2, or 17? Yes, so let's ignore it. What do you have left? If I had sodium cyanide, but you were ignoring the sodium, what would you have left? Cyanide. So really, it's Cn minus that we care about. Do you agree? It's the Cn minus that we think is maybe doing something here. Sodium cyanide produces a pH of greater than 7. So what does that mean to you? It's basic. And if something is basic, what is always in a basic solution? Hydroxide. So when I put this into water, what should your first product of this chemical reaction be? Hydroxide. Because when you put this thing into water, it produces hydroxide. That's the reason why it's basic. So step 1, right? Step 1 is we only care about cyanide. That's the thing that we care about. Step 2 and 3 means write this thing in a reaction with water. So Cn minus plus H2O. What do we know for sure this is going to give us? Wim? Okay. So this is a big leap for some of us, and that's totally fine. What did the water turn into? Hydroxide. So if it turned into hydroxide, what did the cyanide steal from it? It stole a hydrogen. So if this thing stole a hydrogen, what is it going to turn into? Yeah, I agree. Often your product will be a weak acid. If you're starting out with something that's making something basic, often your product will be a weak acid. And if I'm being perfectly honest, there's no way to explain why that is until you get to Chemistry 30. Because if you have a week to talk about this, we could talk about it, but I'm assuming you don't have a week to talk about it. Stephanie?
How would you know that it's like an acid? I mean, that it's a base and not an acid? Like, how do you tell?
Because we did a litmus test and we saw that the pH is greater than 7. You will always be given that diagnostic test in the laboratory. Yeah, you will always be given it. Okay, some stuff's missing here. Now, I should include states of matter because that's all proper chemical reactions should have states of matter. And we should always have our 2 laws. What are our 2 laws for chemical reactions? Wim, give me one. Conservation of charge, and what else? Conservation of mass. So let's look at this. I have one carbon, one nitrogen, 2 hydrogens, and 1 oxygen. So conservation of mass is upheld. And do I uphold the conservation of charge? Yeah, 1 negative on this side, and then we look at the other side, 1 negative on that side. That's how you can determine the charge on the other thing. Just figure out the law of conservation of charge. Okay, does this, I'm asking you, does this explain how when you add cyanide to water, all of a sudden the resulting solution reads as a basic mixture? Does this explain why that is?
Is it always basic?
Well, I don't know. Let's take a look at the next one.
Okay.
Carbon dioxide can react with water in the air to produce acid deposition. So that would be a pH of less than 7, right? So no, it's not always basic. Write a modified Arrhenius reaction to explain this behavior. What I want you to do is I want you to figure out what the formula for carbon dioxide is. CO2. It's CO2. And I want you to reread step 1. Are there any group 1, 2, or 17 ions here? No, so you're not going to do anything like that, right? You can't ignore anything here, okay? That's the first point in number 1. If there are any group 1, 2, or 17, you ignore them, but there aren't any. So we move down to the next step. If the substance is a what? A non-metal attached to oxide. Like carbon is a non-metal, so carbon something oxide. What do we have to do? Use 2 moles of water for every 1 mole of the substance that reacts. That's the rule, and you just have to memorize the rule.
Really?
Yeah. It's actually way easier than you think it is. You're just... What? No, it's not because there's 2 oxygens. It's because it's a non-metal oxide, and when the non-metal oxide forms with water, first thing it does is make an acid, and then it has to react again with water a second time to make hydronium. So it makes an acidic compound with the first water it reacts with, and then it makes hydronium with the second water it reacts with. But again, it's just easier if you just memorize the list. Okay. So step 1 is we're going to take carbon dioxide, but you have to react with 2 moles of H2O because it's a non-metal oxide. So let's write down an equation for that. Carbon dioxide gas. If I want to say that this thing reacts with 2 moles of water, what do I have to write down? 2H2O. And because this thing contributes to acid deposition, what chemical are we going to make? We're going to make hydronium, right? H3O. Do you agree with me that acids contain hydronium? So in order for this thing to make an acidic solution, it has to make hydronium. Okay. Let's think about what's left. How many H's are left? 1. How many anything else's are left? Have we used the carbon yet? No. See? How many oxygens are left? I see 2, 3, 4. I see 4 on the left-hand side, and how many have we used up so far? 1, so we've got 3 left. And you don't have to do anything other than the law of conservation of charge. What's the total charge on the left-hand side?
1.
On the left-hand side. Nothing. There is no... Do you agree with me that there's no charge on the left-hand side? So if we're going to make a positive, what do we have to make along with that positive? A negative. Okay, remember, the thing that you make should be very easily recognizable. Is this a thing you've seen before in your life? Yeah. All the time. This is hydrogen carbonate. This is a hydrogen carbonate ion. This is the thing in baking soda. It's this is the cho in nacho, right? Yeah.
Because when it's like reacts with an acid, it's reacting with carbon dioxide, it's like red
Yeah. That's basically Wim. That's basically the exact opposite of what's going on, right? Is that goes back to Chem 30. Okay. Now, I understand if some of you are lost, and some of you are probably lost because either you're not following.
We should do one more example.
Yeah, I think we should do one more example, but I'm just kind of waiting for people to If you're lost, it's either because you haven't totally committed to learning these 3 steps. I understand this is a wall of words. Do you have to memorize them word for word? No. Group 1, 2, or 3, group 1, 2, or 17, ignore. If it's a non-metal oxide reacted with 2 waters, right? Then, if it's acidic, what does it produce? What's the first product you should have if it's acidic? H3O plus. What's the first product you should have if it's basic? OH minus, right? And then the other thing just has to be all the other elements added up. All the other elements, because you have to observe the law of conservation of mass and law of conservation of charge. That's it. Those are the only 3 steps involved here. So we're definitely going to do one more. 100% we're going to do one more. Sodium acetate produces a basic solution in water. What's step 1? Let's take a look at the formula and let's see if there's anything we can ignore. Sodium is 1 plus, acetate is 1 minus. I had somebody say this was choo-choo one day, and it's definitely not, but that's fine. So, can we ignore one of these things? Yeah, sodium's group 1. Ignore it, right? Okay, so what are we really focused on here? Just choo-choo, right? Okay, so step 1 is I have to react acetate, and how many moles of water am I going to react it with?
2.
It's by default it's 1 unless it's a non-metal oxide, right? Is this a non-metal oxide? Is this a non-metal dioxide or trioxide or quaderoxide? No, it's an acetate ion, so it's not. So we're going to react with 1 water. It's not a non-metal oxide, it's a polyatomic ion. So let's write that out. Choo-choo plus water. What I want to know is this thing going to produce, what should be the first product? It has to be hydroxide. Why does it have to be hydroxide? Because it's a base. Now, I'm being facetious. I'm kind of lying to you. The first product doesn't have to be hydroxide. As long as one of these 2 products is hydroxide, right? As long as it's producing hydroxide. Now, what do I have? What am I going to have left over? What is the water? Remember, the water is either turning into hydroxide or hydronium. What had to leave the water in order to turn into hydroxide? A hydrogen. So if one hydrogen leaves, what does this turn into? CH3COOH, right? And I totally understand. This is a weak acid. I totally get that. But there's no way for me to tell you why you make a weak acid unless we start talking about Chem 30 stuff. Women. Okay. So does this follow the law of conservation of charge?
Yeah.
What's the total charge on the left-hand side? Add up all of these charges. What do you see? -1. Add up all of these charges. -1. We're good. Is that okay? Yeah? Okay, sodium dihydrogen phosphate. Shh. Remember, we talked about this earlier, right? What did I say sodium dihydrogen phosphate was? It was acidic, right? So sodium dihydrogen phosphate can react with water in the air to produce acid deposition. Write a modified Arrhenius reaction to explain this behavior. What is the formula for sodium dihydrogen phosphate? Yeah, I gave it to you earlier, right? So NaH2PO4. Is there anything in here I can ignore? The sodium. Okay, so my first question to you is, can I just ignore the sodium and write H2PO4? So this is a polyatomic ion, right? Does anybody know what the charge on this particular polyatomic ion should be? It should be 1 minus, right? Okay, Wim, you asked, isn't hydrogen group 1, right? Wim, you asked, isn't hydrogen group 1?
It's technically.
No, it's people ask you.
How many times have we talked about this so far this semester?
5.
Hydrogen, yes, I totally agree with you. The way we put it in the periodic table, it sure looks like it's a group 1 element, right? But hydrogen is so special. Have we talked about this before? It doesn't follow any trend. So you cannot consider it to be a group 1 ion. When I say group 1, I mean everything other than hydrogen in group 1. And that's always been our definition of group 1.
It should just be like by itself.
No, it can't, because this is, I don't know, whatever. I didn't make it. Shut up. It's okay. H2PO4. What are we going to react this with? Why 1 water? Because it's not a... So with 1 water... What are we going to make? Are we going to make hydronium or hydroxide? We're going to make hydronium, right? Why do you know we're going to make hydronium? Because this solution is acidic, right? Okie dokie. Now what's the only other thing I'm going to make? If the water gained a hydrogen from H2PO4, what's it going to turn into? HPO4. Okay, the way I've written it right now, does it follow our 2 laws? Nope. I want you to take a look at what HPO4 is in the table of polyatomic ions. It's hydrogen phosphate and it's supposed to be 2 minus. Now does it follow our law of conservation of charge?
Yes.
I have a total of 1 negative over here, and what does this add up to be? 1 negative, right? When in doubt, just look at the table of polyatomic ions. If you can't find it on the table of polyatomic ions, then it's probably not true. Okay, We do not have enough time to go out into the lab today, and that's totally fine. We're going to do it tomorrow. Calm down. Tomorrow we have a quiz. Yeah, okay, tomorrow we have a quiz, but tomorrow we're going to go into the lab as well. Your quiz tomorrow is going to be tiny, 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 short, tiny, itty bitty, little, tiny, super short. Okay? If you're the kind of person that is worried about not having enough time, I'm going to give you 10 minutes for the quiz. Wow. If you do not feel like you have enough time, what are you going to do about that? Come in early and write. That's on you, not on me. That's on you, okay? Don't put your stuff away. You have work to do. Don't put your stuff away. You have work to do. Idris, what did I say? I stressed you out. How did I stress you out? What? It was new stuff. It was one new thing, right? We covered one new thing today. That's stressful, isn't it? Yes. I think people freak themselves out because of the assignment that we marked. The assignment that we marked at the beginning of class, I think some people freaked themselves out and they weren't able to come down. Okay, you have work to do. Just read the question. Use the modified Arrhenius solution to suggest a chemical reaction for the... Hey, all three of these things, they make what? They're acidic, right? So what are they going to make?
H3O.
Hydronium, H3O plus. And all three of these things, all three of those things are going to make hydroxide because they're basic. So try it out. Yeah, if you gotta go, you gotta go. Okay.